Hello everyone, my name is Fahad Usmani and I'm a senior applications engineer here at Primarius. The topic of my talk today is reliability modeling using AgeMOS in BSIMProPlus modeling software. For something about Primarius, it's an EDA enterprise which was founded in 2010 by Dr. Zihong Liu, and its mission has been to provide advanced EDA products and solutions to the semiconductor industry. The company is devoted to build a unique memory EDA flow, delivering innovative EDA solutions and enabling efficient design technology co-optimization in real engineering practice. Primarius offers its industry-standard device modeling platform, BSIMProPlus, which is an industry golden baseband model platform, and MeQLab, which is a flexible RF modeling platform. The distinguishing feature between the two softwares is BenQ offers a cross-operating system between Windows and Unix. BSIMProPlus, on the other hand, it's a complete solution from testing to modeling. It has been qualified by leading foundries and design houses, and it has a powerful simulation engine called NanoSpice, and it can support reliability, statistical, LPE, and so on. Why do we need accurate reliability models? As we can see from the slide, there are several variation sources like random and systematic variations. There are some reliability effects which are time dependent, and also we see from the design margin that it is shrinking due to the supply voltage and the variability. So there is a need for accurate reliability models for design for yield, design for noise, and design for reliability. BSIMProPlus supports AgeMOS reliability modeling. So AgeMOS has been a de facto model which pretty much covers all the standard models: BSIM3, 4, SOI, CMG, HiSIM2, and HV. The old lifetime model can only predict specific electrical parameters degradation related to the ID set, ID lin, threshold voltage, and GM, while AgeMOS is applicable for all bias conditions, geometry sizes, and temperatures. So this AgeMOS model is actually intended to cover full IV curve degradation using the model parameters, which are VTH0 and the mobility parameter. On this slide, I want to talk about how to construct an AgeMOS model. So there are simple reliability equations with the fresh model, and then there is an AgeMOS model. So the AgeMOS model allows faster simulation because there's no interpolation or regression involved. So as you can see, the first one is the fresh model card, and then there is a reliability model card which can be simulated, which is being simulated using the expert software. And similarly, you can construct a AgeMOS model for a given model parameter, such as threshold voltage. As you can see, for HCI, for NBTI, and PBTI, it's going to have its own set of AgeMOS parameters. For AgeMOS model construction, you can see the input needed is, of course, there's a schematic, there's a SPICE netlist, there's a SPICE model, and the reliability parameter, and the reliability spec. But for the reliability model part, there are two key aspects of it. One is the SPICE parameter, the other one is the reliability parameter. So they can be grouped into HCI-based, BTI lifetime parameters, and the AgeMOS specific parameters. So this table below gives you an example of each category of reliability model parameters. AgeMOS supports both global and bin models in either core format or model format, macro model format. So as you can see from the slide, that it gives you just an example of what would a AgeMOS model embedded within a bin model would look like versus what a global model would look like with embedded AgeMOS model parameter or AgeMOS model card. So the AgeMOS modeling flow in BSIMProPlus looks like this. The first step is to take the device measurements, which can be DC and AC measurement, which will collect IV, CV, and I-sub and I-gate data, which is fed into the software, and that helps us extract the fresh model, also the I-sub and I-gate model. And on the other hand, we also need the stress measurement module to get the degraded IV and the stress measurement data. That way you will have the lifetime model extracted as well as the AgeMOS model parameters extracted from the degraded IV and stress data. And combining the fresh and the aged model, we get the reliability model library, which can then be simulated using a like a NanoSpice, RelicsPert, or any other Spice simulation engine out there. I want to briefly talk about the AgeMOS modeling for FinFETs. So in BSIMProPlus, we have done some enhancements for AgeMOS modeling. So we have enhanced HCI and NBTI effects pertaining to FinFET model, which is BSIMCMG, and it also had incorporated a self-heating effect in the AgeMOS model. So now we have more device controllers like bulk mod, geomod, SHMod, and impact ionization mod. The parameter binning calculation is there for length and fin. There's a temperature dependency. There's an HTI model, which has impact ionization current model for devices without the body contact, and then there is a BTI model, which has the T-fin dependence included along with the bias dependence. AgeMOS model for NBTI would look something like this. As you can see on the left hand side, the ID set percentage, the delta is shown with respect to time. The degradation is without self-heating, and when you simulate the degradation with self-heating, you can see the fitting looks pretty good. Similarly, on the left hand side in the bottom, it shows the gate voltage dependence and the fin thickness dependence for the BSIMCMG model. Lastly, about the Primarius products and solutions, we offer advanced test, SPICE modeling, and PDK development and verification tools, not to mention the stem cell verification tool, design platform, circuit simulator, and design for yield platform as well. For more information, please visit our page primariustech.com, and you can also send us an email at inquiry@primariustech.com. Thank you very much.